All right, so this is Math 221C, Social Statistics, Group Meeting 3, I believe, or Group 8. Yes, for Group 8. And this is quiz number 3. So, does
Wait,
anyone have any
we on
questions?
I am on the wrong one. Give me just a second.
You're on the
I'm around
wrong
lesson
quiz?
4. I'm around lesson 4.
We are on
Week 3, lesson 4.
Yeah,
4.
week 3, lesson 4.
Okay.
This is our third little meeting.
Got it. Making sure I'm on the right one.
On the chat. All right. So, does anyone have any questions on the homework?
Nope.
I think I had a question on the very last question
Okay.
about the dice, the 8-sided dice.
Okay.
And it said, calculate the probability of not getting a number greater than 5.
Calculate the ability. Let me open it up.
So how I see it is that I'm not going to get a number greater than 5. So I have 5 chances of not getting a number greater than 5 on an 8-sided die.
5 chances, not 4.
Because it's 5 or of not getting a number greater than 5. So you still add the 5 in your calculations.
It's 5 not
okay,
greater
that's
than 5.
Does that make sense?
Okay. Makes sense.
Cool.
Thanks, guys.
Any other questions?
Nope.
Alrighty then, let's get started on the quiz.
It's pretty easy. I already started it.
All right, guys, go ahead and answer your precursor questions. Alrighty. Do you want me to read it out again or read the question?
Yeah, go ahead and read it.
All right, guys, here we go. Question number 3. All right, use the following information for the next 3 problems. Human blood can be classified into one of our basic types, O, A, B, and AB. The proportion of people in the population of the United States with each of these blood types is summarized in the following table. Presented table. The blood types and the proportions given in the table above define the probability distribution. True or false?
True.
That would be true.
True.
Good job, class. Question number 4. What is the probability that a randomly selected person in the United States has a type O blood? Round to the 2 decimal places.
Pretty easy. 0.45, like on the table.
0.45.
Say?
The question is, what is the probability that randomly...
I can't hear you.
Yes?
Sorry, what did you guys say? It froze on me.
Question 4 would be 0.45, since that's what it is on the table.
On the table, okay.
Of the chances of having a type O blood.
Okay.
And then, what is the probability that a randomly selected person will not have type O blood? So we go and add A, B, and AB together, which we would get 0.4 or 0.55.
Yep. Or you can just take 0.45 away from 1, which is the same thing.
It's 0.55?
Yeah.
Okay. Does everyone agree with that?
Yeah.
All right, so next question. Caroline Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from the bladder cancer patient. Tangle, one of the dogs, demonstrates the identification of the specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. If the dog's guesses at random, what is the probability that it will correctly identify with the dish containing the specimen from the bladder cancer patient? So there's 7 bowls.
Did not have.
So it'd be 1 divided by 7, which would be 1.4. Or 0.14. Everyone agree?
Yes.
1.43 because he says we have to round up to 3 decimal places.
Oh.
And so you just round up.
Okay.
Everybody gets that.
Good catch.
And round up. Okay.
Round up, because then it's the 4th number is the 8, so you got to round up to 3.
Yeah.
Okay. Cool. Thanks for saving.
You're welcome.
All right. In a combined total of 54 trials, the dog correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate? This provides strong evidence that dogs can detect bladder cancer. There is little evidence that dogs can detect bladder cancer.
I think it would. Provide, go ahead.
Go ahead, no.
I think it said it would provide strong evidence, since it says in the question, it is very unlikely the dog would do this well by random chance
Hey,
alone.
you guys, my thing has a crack in it and it's wigging out. Let me hang up and call you guys back. Is that okay?
Yeah.
Okay. I would agree with you there, Jake. So,
We'll see what everybody else thinks about the same thing, too.
okay. Speak now or forever hold your peace.
I have a question. So like if I wanted just to go to the Google Hangouts without having you guys to always call me, how do I find you? Does that make sense?
Yeah, so if you wanted to actually like set one of these up, you go to YouTube, then you click on like the little tab to the left, so that gives you a bunch of options. It's like in the left-hand corner. And you click on that, and then you go to live stream, and then it says events.
Mhm.
And then you click, and then there'll be up in the right-hand corner, there'll be one that says live event, and that'll shoot a Google Hangout out. So,
Not to everyone
and then
do-
you can,
Sorry. My iPad was wigging out.
it's okay, we'll forgive you just this once. Next time you're gonna have to walk the plank.
The next thing, you got to do it by yourself.
Yeah, we are helping you.
Okay.
Jeez. Just kidding. All right, question number 8, guys. Let's get rolling. If you reach into a bag of plain M&Ms, what is the probability of drawing a red-colored candy? Round answer to the nearest decimal.
Right there, 0.13.
Correct. Good job, guys.
Yay.
Same thing
What
for the
is the
green.
probability? Yep.
Hold on,
The
sorry.
green, we have to add them all up. Which it would be.
I got 0.16.
All right, minus 13. I got 0.16.
Here as well.
Everyone agree? Everyone concur?
Yes.
0.16, yeah.
All right. What is the probability of not selecting a candy that is not green? So it would be 0.184
There's 0.84.
or 0.84. Sorry, guys.
Because the whole table equals 1, or that's what the probability should equal is 1.
Yeah.
And so I just subtract the 0.16 from that. And
Yeah.
Cool. All right, guys. Question number 11. The ACT scores of the students admitted to the medium-sized public university in the Western United States were taken from Compex.com. The following summary statistics were calculated. Half of the observations are less or equal to what number?
it would be 24
Mhm.
median.
That's what I would say.
Wait. The median 24. Yeah. Yeah.
It would be
That's the middle
24.
number,
Yeah.
Mean is an average, right? And median is just the middle number, correct?
Yeah.
Making
I would
sure.
agree with that.
Average. Yeah.
Based on the information on the table above, the top 25% of the students scored above what number?
Quartile 1, so what, 22 or 14?
Twenty-five percent of the students scored above what number? It would be 27.
Quartile
So
3,
that'd be the
that's
Q1. 'Cause that's 25%.
Yeah.
the 22.
So it'd be 22, yeah.
The 22.
Everybody concur?
Yep.
Yeah.
Cool. You guys are easy to deal with today.
I'm ready for bed, so
All right. Which of the following statements is not one of the three rules of probability? The probability that an outcome will not concur is one minus the probability that will occur. A probability is a number between 0 and 1. If the probability is high, then the probability is positive. If the probability is low, then it's probably negative. The sum of the probabilities in any probability is 1.
I think it's the third one.
Is it C?
Yeah, C. Yeah.
See? Cool.
Let's see what we got. We got question 12 wrong.
I was fixing to say like the problem. I don't.
Oh, the top 25%.
Yeah, that's what I was. That's what I was saying. The third
That's what
quartile.
Table
I
above
was
the
hesitant
top
because I
25%
think it was that one.
students scored above.
Yeah.
Hold on. All right.
It'd be the third quartile.
Yeah, so it'll be the 27.
Yeah. I was right. Sorry, guys.
Dang it. Next time we'll listen to you.
Just kidding. I was right. I will say that. All right. So this time on Thursday, does that work for everyone?
Yeah.
Yep.
All right. Cool. Well, that's the end of the broadcast.
See you guys then.
Thursday,
Wow, Heather.
guys. I know. I'm sorry.
Just kidding. What time?
Just ruined it all. So I don't get off until 8 p.m. Arizona.
So what would that be our time?
So Idaho
I think
time, that's. And Lisa, I think it's 10 your time.
It is.
Hmm.
Yeah.
And I work Friday too. And I'm really sorry. I'm
Do you want
spacing out my working. It's
tomorrow?
going to be changing. So
Oh, is tomorrow too soon to meet?
I work tomorrow night, so
So do I.
We'll just leave it. It'll be fine.
Okay, we'll figure it out.
sorry,
We'll just
guys.
keep texting each other. No, you're good. Have a good one.